So, good morning, and thank you for joining the session leveraging advanced technologies with a focus on data cubes. And thank you.
Good morning, everyone.
And good morning, and thank you to the speakers for their amazing videos that set the broad scope for our discussion this afternoon. I hope you have all watched these videos posted online on the symposium website, as we will not present them to keep as much time as possible for live discussions. The presenters will only highlight short summaries for the videos. My name is Marie-Françoise Voidreau. I work with the Open Geospatial Consortium in Europe as a director with the Innovation Programme. With support of all major stakeholders, OGC has produced a geospatial coverage data cube community practice and is pushing a lot of works on APIs to support data cubes interoperability. Before working with OGC, I worked for more than 30 years with Météo France, the French weather service, on sophisticated information systems, managing multidimensional, heterogeneous big data in a very user-centric and applied approach. So we did not call that data cubes, but it was looking alike a lot. I am delighted to moderate this session with Thierry Ranchet. I work very closely with in the H2020 eShape project. Thierry, I'll let you introduce yourself.
Thank you very much, Marie-Françoise. Good morning, good day, and good evening to anyone. I'm Thierry Ranchet. I'm part from Mines ParisTech, which is an engineer school in France, and I'm involved in GEO since 2005 and in the program board since its inception, mainly working on energy and Earth observation. And I'm delighted to present with Marie-Françoise this interesting session talking about the tubes and the cubes and the different elements that we are going to use for all our activity. And that's very interesting to look to this advanced technology on the first session. And so following what have been produced and present this on the first session of the afternoon, it will be great to have all of the presenters around us to share their experience and their knowledge about the data. So we have a 90-minute session, and we have a series of presentations that are going to be done by the different presenters. As Marie-Françoise explained, we have, of course, a series of videos that have been first prepared by all the presenters. I hope you had time to take a look to them. If not, please do it because it's really interesting. And so we are going to use the Slido tools like in the other session, using the hashtag GEO for connecting to this SO5 presentation. And so we have a presentation that are going to be done. Thank you. The next slide. So that's the title of our session. And so you have okay. So here is our bio, and we have the main focus on this session is really the interaction with the presenter. So please use the Slido and the event code hashtag GEO with the selection of session 5, and feel free to ask any question you have linked with the data cube. And so we will, of course, try to remain open for the 40 hours after the session and trying to answer to all the questions. So next one is Eric. That's, of course, our bio. Next one. So the first presentation is not going to be the data cube, but it will be a presentation by Gilberto and Marie-Françoise. Up to you.
So yes, the first presentation, and this will be the only full presentation, even if Gilberto has posted a longer video on YouTube. The other presenters will just highlight some a summary of their presentation. And the first presentation will be given by Gilberto Camara, you all know as a director of the GEO Secretariat. But before and while being the director, Gilberto is also a researcher in GIS science, geoinformatics, spatial data science, and land use change. So he has a long career of GIS and very applied until visualization. I met him with that many years ago, and so I'm very delighted to open this session with you, Gilberto.
So thank you, Marie-Françoise, and welcome everyone to the GEO Symposium. I hope you can see my slides. So I am delighted to give you a certain introduction to the issues of data cubes and benefits and challenges, and as a certain introduction to what is going to be said today. So, I think Marie-Françoise already presented. My life as a researcher. I am actually acting director of the GEO Secretariat, and I was director of Brazil's National Institute for Space Research. And you can find me more information about me on www.gilbertocamara.org. Right. Okay, the whole business of the data cubes and the whole business of, let's say, the technology that we're putting in GEO is that we want the development of the technology to be at the service of the community. And therefore, what is the whole here of these data cube technology is to make the data, 40 years of Earth observation data, more and more data, accessible as analysis and modeling. As those who have seen the Centuagri this morning, the session, saw that the benefits of the clouds are really important. They empower people to use Earth observations in ways that were not possible before. So, as a prelude to the presentations this afternoon, I'm going to give you an overview of some topics here. What is a data cube, after all? Why are data cubes important? How to build data cubes, how to describe data cubes, and how to access and use data cubes, because these are questions that we all have. Let me start with the first one. What is a data cube? And I'm going to use, first of all, there is no standard definition for that. This is, let's say, the view I hold, but also other players like Edza Febesman, which is a good friend who is a professor at the University of Munster. This is like, I think we have to agree on some definition. This is the proposal we have. So the data cube is a 3D array with two spatial dimensions, one temporal dimension, and an arbitrary number of attributes with the following properties. The spatial dimensions are aligned with the spatial reference system. So when you walk in space, you walk on UTM or lat long, or whatever, Albers projections. The cells of a data cube have a constant size, so they are comparable. So it's either 10 meters, 20 meters, 30 meters, 5 meters, or 500 meters. There is no spatial and temporal overlap, so each cell covers a specific and singular space and time slot. We know what the intervals are from one to the other, and for every combination of dimensions, you get, for example, the values of the attributes, bands or indexes and so on. This is, let's say, graphically what I'm talking about. You have a latitude and longitude and time, and you walk in the cells. Okay, why are data cubes important? I think it's important because they provide continuous information. They make the big data available to its foremost. Not a single image, not two images, not three images, but in principle, the best combination of images available. With that, one can understand and do things that were not possible before, which is really to do the continuous monitoring of landscapes. We can look at a point in certain place in space, in this case in Brazil, and see, well, this has been a forest for the last 20 years. This was being agriculture for the last 20 years. This was a forest which was converted into pasture, then converted to agriculture. You really see what was happening and all the transformations that happen on that place. And that is a continuous monitoring. Building data cubes, as we will see in the presentations today, is not for the faint of heart. There are a lot of technologies involved. You have to do the selection of scenes that compose the cube. You have to do the cloud and shadow detection. You have to do the topographic and atmospheric correction. You have to do geometric warping. You have to do the temporal pixel compositing. It's a lot of work. It's really cumbersome in terms of steps, and they have to be automated. So the first thing you have to say, I'm taking an area here, and I'm going to select all the images that fit these areas. And this sometimes involves going to 2 or more combinations of the scenes provided by the satellites, reorienting the satellite, and doing a lot of work on, selecting the best scenes. You also have to deal with the fact that you need to select the clouds. It's not an obvious issue, because there are different cloud algorithms. This is a recent paper one student of mine has published, and it shows that there are different algorithms, for example, for Sentinel data. This is the example we had, and they perform differently. So you have to select a good mask that meets your needs. Now, you also have to correct for the atmosphere and the topography. So this is one ISA shows. This image on the left is without atmospheric correction. The image on the right is with the atmospheric correction and with the reflectance. Now, not on the top of the atmosphere, but the reflection, the surface reflection data, which is fundamental. And finally, if you have those images, you may have, for example, Sentinel 2A, 2B, and Landsat for 1 month, and you have to select the best image or the best pixel. Or you may select the combination of 1 pixel from one image or a second pixel from a second image, in which case you have to be sure that all signatures from different satellites really match. So this is a really specialized thing, and it requires a lot of work. And that's why it's important, the work that our teams are doing. Now, once the data cube is built, there comes the next step. The next step is assessing the data cube. Assessing the data cube is also not trivial, because developers have chosen different ways to store the data so that the implementations can be very different. So the Google Earth Engine, which is a data cube, implements differently from the Climate Data Store, from the Brazil Data Cube, from the Open Data Cube. So this is also an issue that we have to deal. The way to deal with this is something that has been shown by the Open Geospatial Consortium, is the use of web services. If you have different implementations, but if you want to have a single way to access those implementations, you need to be able to find out what are these guys, what do I have for you, and hopefully in an application independent way. So you have the single protocol that you can ask the different providers, much as we do now with the web feature service and web coverage service and web map service. This is one of the great benefits of web services and one of the great benefits of the OGC. We need to improve now this to support the data cubes. A simple example which is implemented currently, it's under implementation, is, for example, a time series. Suppose that you had all of the data cube providers saying, I agree to a simple protocol that give me a time series for certain location given the data cube, and I don't need to know how things are implemented. I get the data cube. So there is a prototype. This is something that has been developed as a prototype in Brazil that shows the way forward. But this is not the only need. The other important need is, given a data cube, how to describe its content. And here there's more progress here. And the progress is because there is a huge, let's say, community development around the Spatial Temporal Access Catalog, STAC. And STAC is a very promising technology. that allows to describe a data cube in, I would argue, in a fashion independent from the actual implementation. So this is something which has to be looked very carefully by the community. And finally, the next step, and most important, I would argue, is a common API. Instead of having to program in a Google Earth Engine using the Google language, the Open Data Cube using the Open Data Cube, and the Brazil Data Cube using the Brazil Data Cube, you need really a consistency of one code and many platforms. And this is, again, an important challenge. Now, after you have everything, that you haven't solved the problem, because the next step is how to use them. Suppose that I have the data is organized, and then you still have to make available a set of open source techniques using, for example, but not limited to, machine learning as means of classification, because data cubes really enable new methods. They have a huge promise, but that promise has to be matched with techniques which are robust. What we have found by working with data cubes is that there is an elephant in the room. The elephant in the room is the variability of our ecosystems. Our ecosystems in the world are quite variable. You cannot, global maps are doomed to failure. It's much more important to rely on local knowledge, because the Brazilian savanna is not the African savanna. For example, we don't have elephants. And it's completely different, although they have the same names. So you cannot simply say, I'm going to do a global map for everyone. That doesn't work. Local knowledge is essential because ecosystems are highly variable. So we have a situation where there is a need of a combined effort of both the practitioners, the engineers, and the scientists. We have not solved the problems of the data cube. We have seen how important they are. So we need a combination of science to develop open source tools and open knowledge ways, and perhaps engineers who use the learning developed by the scientists in order to build robust solutions. That, in the terms of the GEO Secretariat, has to be underpinned and supported by open science. We don't see any way to progress in global problems unless we do open science, open education, open access data, open peer review, open methods. This is something that the collaborative network is favored. I don't see how we make significant progress in the global world without a full adherence to open science. So to sum up, what's the challenge? We need open source, widely available, efficient and well-documented methods for providing analysis-ready data and data cubes. We need standards for describing the contents of data cubes and extracting information from them. We need open source, widely available, efficient and well-documented methods for big Earth observation data analysis. And finally, and perhaps most important of all, we need public cloud services that support the GEO community to use open EO data and tools with, respecting concerns of privacy and cost. There are good starts like FAO CIPO and ECMWF Climate Data Store, but they show what can be done. They are not the final, and I hope that by working together in a full open way, we can really develop the infrastructures and the support for data cubes and cloud applications that the GEO community needs. Thank you so much for your attention. Thank you. Marie-Françoise, over to you.
Thank you, Gilberto. That was a very brilliant presentation about the data cube, first insight, and allow us to understand better the follow-up. So the next speaker will be Gregory Giuliani from the University of Geneva and UNEP. So Greg, the floor is yours.
Thank you, Thierry, and thank you to Gilberto for the great presentation and great introduction. So I'm really pleased to briefly discuss what we achieved so far with the Swiss Data Cube. So the Swiss Data Cube, just to remind you that this is an initiative from the Swiss government, so the Federal Office for the Environment, that gave us the mandate to look at the technology of the Data Cube 3 years ago already. And then incrementally we engage with them, we work with them to test the technology, then to apply it, and now to operationalize it, meaning that at the moment, at least in Europe, we are the first full national data cube, and among one of the first around the world. And one important point that I want to raise is that we wouldn't have been able to set up the Swiss Data Cube without the help of the GEO community and without especially the help of CEOS and NASA, and especially also obviously Geoscience Australia, because thanks to the GEO community and the discussion we had within the GEO community with Geoscience Australia, we came up with this technology. We learn about this technology. They teach us how to install the software. So we had the support of Brian's team to also at CEOS to implement the Swiss Data Cube. And now on our side, now we are teaching around us. So at different countries, for example, we have a small project that is supported by a small fund in Switzerland for knowledge exchange. So now we are supporting Armenia to develop their own data cube. So now the concept of data cube also, it's a kind of pervasive concept, and we are learning from each others, and I think that's the power of the collaboration, and really that's one of the main power of the GEO community. So Rick, if you can just change the slide, please. Oh yeah, that's my bio, but that's okay. We can just I just made a couple of points through the presentation that you had a look through the video. So I think what is really important, at least from the experience that we have discussing with the government and working at the national scale, I think that's one important point is that the work that we are doing with Earth observation data should be as much as possible embedded in national digital strategy, because basically now every country in the world has a digital strategy, and from my point of view, really the data cube technology should be embedded in those strategy to support as much as we can also the development of evidences to support policy making processes. The second point, obviously, and it has been perfectly raised by Gilberto, is all the interoperability challenges that are around the data cube, no matter what implementation we are using. Yeah. So, for example, the Swiss Data Cube is based on the Open Data Cube technology and software stack. And really recently, we have implemented OGC services. So now the Swiss Data Cube is accessible through WMS and WCS, so meaning that you can access really the data. And now we are working with Geoscience Australia also to implement the WPS, so that also we have at least one way to share and exchange processing algorithms. But obviously the next step will be to look at a common API, or allowing to the different data cubes to talk to each other. And we are also currently investigating how best to implement the stack protocol on top of the Swiss Data Cube. And I was mentioning before, we're really committed to support now other people and other countries and other centers to use the Data Cube technology. So we first developed in the frame of the project that we have with Armenia, the bringing Open Data Cube into practice teaching material. So it's a freely available material where you can learn in a couple of hours how to install the necessary software and how to ingest data. and then start working with the data that you store in your DataCube instance. So that's the first step, but we had in mind to expand and to facilitate the work of users. It's a kind of, I would say, approach that is similar to the analysis-ready data. So the analysis-ready data has lowered dramatically the barriers to work with the data and to access the data. But still, it's really challenging to install all the necessary software. So we have developed what we have called the DataCube on demand. So now, based on simple requirements, we have developed an API that allows a user to just to define a set of sensors between the Landsat 578 plus Sentinel-2, and select an area of interest, and then select a temporal frame. And then in a couple of hours, we instantiate a DataCube instance, and then the user receives just an email with the link to the Jupyter notebook, and then the user can start working with his own DataCube. So that's a way we think that might be relevant also for the user community, and especially if we think also about the reproducible knowledge. And I think in our team we are really committed to what Gilberto said before. We want to make all the work that we are doing with the Swiss DataCube as open and as reproducible as possible. We are about to submit a paper, a data paper into a Nature Scientific Data, where we explain in detail all the material we have developed to pre-process the data, ingest the data in an ODC instance, and then we have a DOI for each specific sensor we ingested, so Landsat 5, 7, 8, Sentinel-1, Sentinel-2, and so on. And all the code that we are generating is freely available, documented as much as possible. So we think this is the only way to go if we want to achieve the last point, is to really enhance the scientific accountability and credibility and reach really the decision maker with good scientific information. So that's really something we have in mind. We want to apply, we want to support, and we really encourage all our colleagues and all the people that are involved in the DataCube to go to community to go in that direction, because I think that's extremely important, especially in those times where I think there are a lot of fake news and misconceptions and so on about the environmental issues. So I think that's extremely important. And that's it on my side. Thank you.
Thank you very much, Greg, for this presentation on a national DataCube to support decision making. And the next presentation will be given by Dr. Brian Killock, who has been working with NASA for more than 30 years. Brian also leads the Committee on Earth Observing Satellites, which is more well known by the acronym CEOS, System Engineering Office, which supports the International CEOS organization, which is comprised of 60 space agencies and organizations coordinating satellite Earth observation data for enhanced societal benefit. So a major stakeholder into the landscape. Brian will inform us about the status of the Open DataCube and the Open Earth Alliance, and about his vision for a full network of DataCubes. Brian, the floor is yours.
Yeah, thank you, Chair. Thank you very much. I think you said I lead CEOS, which is far from the truth. I'm just this little piece of the puzzle that is involved in CEOS. So happy to be here today. If you can move to the next chart. I think there's two short summaries. Next one. One more past that one. Okay. So I think what I have here is just the absolute brief summary, but I have a few other things to add to this. So there's two topics that I had in my video presentation, and if you take a look at that, you'll see more detail. One is on the Open DataCube and where we're going there, and the other is on a new activity called Open Earth Alliance. So regarding the Open DataCube, many of you know what we've been doing here for quite some time, and thanks to Greg, who was one of the first people to really take it and run with it and is doing some amazing things. It's great to see Greg part of the community, and the community has grown quite rapidly. So our ultimate goal is really to have a network of these interoperable data cubes around the world. Gilberto also brought forth some of the ideas that are going to make this difficult for all of these to connect, and the interoperability issues and the different platforms we have to deal with. So it's going to be a long road, and we'll have to figure out lots of different paths to get there, and likely the technologies will even change along the way, but it's an exciting opportunity. A few things I wanted to mention that are also in my video are some of the new activities we're doing. One is a Landsat sandbox. So by the time that the Collection 2 data for Landsat is released on Amazon, it's about a few months away, probably September timeframe, we're going to have a sandbox available for anybody to go to and use Open Data Cube technology, run some algorithms, and run analyses anywhere in the world. I would say it's analogous to what Google Earth Engine can do, but it's going to be using the framework of Open Data Cube and the approach that we have, and therefore you could then go reproduce that anywhere you wanted in your own cloud infrastructure. We're also working on an Earth Analytics Lab, which is a cooperative project from within CEOS, WIGIS, and my group doing interoperability test bed that's going to support some CEOS projects and likely some of the GEO tasks as well. Later on, you're going to hear from Grega at Synergize. We've started a new collaboration with Digital Earth Africa, Synergize, and my office to develop a Sentinel-1 ARD pipeline. So that the idea there is to create an analysis-ready data product and to have the ability to generate a Sentinel-1 data cube anywhere in the world, any size and shape that you want. There's really nothing like that right now, not easily put into a cube framework so that we can utilize these common algorithms. In general, we've been spending a lot of time working on bringing the algorithms up to date, making them work better, cleaning them up, and hearing a lot of feedback from users on what is the best way to go. So that's where I've been spending quite a bit of time, and our team has made some great progress on what we call a handful of master algorithms, things like mosaicing and water extent and vegetation change and phenology. We're also working on some linkages now to weather data, soil moisture, and developing some algorithms for the radar data like Sentinel-1 and ALOS. So a lot of exciting new things coming along. All these algorithms are free and open, and we're going to work harder to make sure that they're in a common repository with training components going with them. And then finally, SDG toolkits. Just to mention that we have an emphasis on the water extent 661, some work with urbanization in 11.3, and also land degradation. So as these toolkits evolve, we're going to have some contributions there from the Data Cube. So the last thing I wanted to mention was this new idea of the Open Earth Alliance. This is a brand new concept that's been put forth as a GEO community activity. Gilberto's aware of it, and we just recently got this approved. So we see this as the next logical step for where the Open Data Cube community can really expand and move forward. Up until now, we've been focused on just a few partner organizations that have made the primary contributions and the advancements. What we'd like to see is a broader community of involvement. And so we're thinking that something like an Open Earth Alliance under the umbrella of the WMO Geo Trust Fund will give us more flexibility and the ability to test new technologies and to optimize the impact of what we're doing. So though Open Data Cube would be a primary piece of that, it's technology agnostic, and as things change, we might want to investigate other ideas. But basically, it's things like open source solutions, algorithms, and analysis hub, and doing that within something called an Open Earth Alliance might give us the ability to get some other contributors involved. So I'll stop there, but there's certainly more in my video, and thank you very much.
Thank you very much, Brian. That was a very interesting video, and I recommend to take a look to it if you don't do it before the session. That's really impressive what you present, and there are a set of ideas that we will discuss later on. So the next speaker are two speakers. It will be about the EO Data Cube for Brazil, and we will have Karina Ferreira and Gilberto Queiroz that are going to present their work through the Brazilian Data Cube. Thank you, and the floor is yours.
Hi, thank you everybody. Thank you for the opportunity to present our project here. So we will present a summary of our presentation that is available there in the Symposium website. Next, please, Chair. Next slide. Okay. So the Brazil Data Cube project started last year, and it has main 4 goals. The first goal is to create analysis red data from medium resolution images for all Brazilian region, including images from the satellites Cibers 4, Landsat 8, and Sentinel-2. For us, this is a big challenge because Brazil is a huge country. For example, Sentinel-2 is the biggest image collection that we are handling in the project. Almost 700 terabytes of data. So as Gilberto mentioned, it's only possible because we are using a cloud environment. We are using Amazon Web Services to process this data set. Thanks to GEO and AWS, because we are using the credits that we win in the GEO and AWS program to do that. So the second goal is the creation. We are creating multidimensional data cubes from these analysis red data image collections. So in our presentation, we show how we are doing it based on temporal compositions and corrections of satellite images. The third goal is to develop and use big data technologies and machine learning methods and image time series to store, process, and extract information from these image collections and data cubes. And the last goal of this project is to create land use and cover information for all Brazilian territory using the methods developed in this project and the data cubes and image collections created here. In the project, we defined a grid, as you can see in this picture. We defined a grid composed of 560 tiles, as we explained in the complete presentation. Next slide, please. This picture shows an overview of the Brazil Data Cube project. So we are creating these data cubes, multi-dimensional data cubes, from medium resolution satellite images. And we are using neural network to select good quality land use and cover ground samples. And we are using machine learning to classify the time series extracted from these data cubes that we are creating in the project, and to create the land use and cover change maps in Brazil. So the methods that we are developing are available in an open R package called SITS. And we started to work on this workflow in 2016 in a precursor project called Essence. And we explain this in our presentation. Next, please. So in the Brazil Data Cube project, we are producing open data and open source software products. So besides the analysis red image collections and data cube that we are producing the project, We are also organizing land use and cover samples, ground samples of land use and cover classes, because we use it to train the machine learning methods that we use in the project. We are also organizing land use and global and local land use and cover data sets that we are using in our web services, in our internal infrastructure of the project. The software that we are developing include web services. So we are developing a lot of web services to query, to process, and to access the data and metadata that we are developing in the project. We are using the Spatial Temporal Asset Catalog to disseminate the metadata of our data, cubes, and image collections. We are also developing using OGC web services. So we present this in more detail in our complete presentation. And we are also building applications with graphical interfaces for final users. So we are developing a web portal of the project. And using this web portal, we can download the data, we can assess and do some analysis in our data cubes. And we are also using Open Data Cube. You have an instance here of Open Data Cube. We are using the Jupyter notebook provided by the ODC, accessing our data cubes. So this is an overview of the products that we are developing and creating in the Brazil Data Cube project. Next one. So thank you. Gilberto Queiroz, do you want to add something?
Okay. Hi, everyone. Good morning or good afternoon. I'm also very pleased to be here today to present with Karine the Brazil Data Cube. As she has already summarized very, very well the Brazil Data Cube project, I would like just to add that this project has also a very important role in bringing the knowledge of Earth observation data cubes to a young generation of remote sensing scientists, engineers, and students in Brazil, besides, of course, enabling better applications and providing sound information to Brazil stakeholders. So this is also another part or contribution of this project. I would like also to reinforce that we are very committed to have everything we are producing as free and open source, from the software to the data, and we are very open to collaborations. So this is pretty much what I want to say. And so I give the floor back to Terry.
Well, it's to me now, Gilberto. Thank you very much.
Sorry.
No problem. We switch, Thierry and I. So thank you very much for this impressive example of integration done in, if I understood clearly, in something like 1 year. As you said, that the project began in 2019. It's a lot of knowledge and technology which has been integrated, driven by a good understanding and knowledge of the problem you want to solve of land cover. So this gives the impression that the data cubes are not a source of problem, but are really helping. So the next speaker will be Fang Yuan from Digital Earth Australia. And Fang Yuan is the Assistant Director for the Product Development Team in Digital Earth Australia program. And since 2017, Fang has been involved in the development of satellite imagery-based products for applications related to natural resources, disasters management, land cover, and change monitoring. And right now she's supporting the Digital Earth Africa establishment team and which also involves a lot of, I think, of capacity building, and she will summarize her video now. Thank you, Fan.
Thank you, Maria. Good evening from Australia. So this slide is really try to remind everyone what is presented in the full presentation, and more details can be found there. I guess I'll just try to emphasize a few key points here. So the two programs that I work for are the Digital Earth Australia program and Digital Earth Africa program, which is in its establishment phase. So both of these programs are continental scale implementation of the Open Data Cube technology. And the other thing to mention is that both of them are funded to be built as operational platforms. That means we're managing petabytes of data for these two continents, and the input data sets are continuously being updated as new observations become available. The infrastructure is managed and monitored so that it's always reliably operating, and also the derived products are generated whenever possible. So there's definitely a common theme between what these two platforms trying to address, like the natural resource management and trying to support economic growth. But apparently we're dealing with very different challenges for these two continents, and that's why we take a user-centric, a user-led approach for both of these programs, which means we actually try to understand what data sets the users will want, what infrastructure the users can use, and what tools will be most efficient and useful for them, and also what information products we try to come up with. And at the technology level, both of these programs are at the core supported by Open Data Cube, but this is really just linking input data and outputs and interfaces to analysis environment. So the input data we work with are mostly free and open data, and our derived products are free and openly accessible as well. So the users are free to access these data directly, in addition to use the Open Data Cube supported interfaces to interact with them. And we do have, as mentioned before, OGC web services, visualization portals, and sandbox analysis environment that user can use to interact in different ways with our data sets. And I really want to emphasize the usefulness of the sandbox analysis environment. So we've built this as a Jupyter Hub environment. So it's entirely built in the cloud and free to sign up to use. And we've implemented it as a very scalable architecture as well. So this would be the main environment to interact or do analysis with data, the Africa. So we've implemented a way to continuously adjust how the environments are set up so that we can meet the different needs of different users. That people can ask for more or less resources, depend on what kind of analysis they're likely running. And also this environment, our team is using it actively for our research and development, but our users are increasingly using this environment as well. And in particular, we found it to be really valuable when we engage with industry. So through our both our incubator program and our other experience working with industry users, we the common theme there is data available through the cloud and accessible through the cloud, and also optimized for accessing through the cloud. So really, I can't stress more of the importance of the underlying data sets, the analysis-ready data underpinning all of these services. So as one of the examples that it's really exciting news is that for Africa now, we host all the Sentinel-2 data available and in cloud optimized format. So this is really going to make the analysis really more efficient. And also we're taking a different approach for the Africa that we want these analysis radar data input pipelines to be sustainable. So we're working with data providers directly to get these input data sources. And the last thing I want to mention is really that I think a lot of the value of the Open Data Cube community comes from the sharing of these resources and learning and algorithm. I mean, we have 2 platforms built and by the same team, and it really saves a lot of time because we can use a lot of the algorithms and technologies developed in these 2 programs. And we work very closely with our ODC partners as well. So for the sandbox, we've built this repository of notebooks with algorithm and examples, and a lot of these we are developed with our partners. So I'll actually stop there, and happy to take questions after the session. Thank you.
Thank you very much, Fan, for your presentation talking about 2 continents. So that was really impressive, and the video is also very knowledgeable. So thank you for that, and we are going to our last presenter, last but not least, Gregor Milzinski from Synergize. So Gregor, the floor is yours.
So thank you. Hello, everyone. So my name is Gregor Milzinski. As mentioned, I'm from Slovenia, and since we have quite a few talks about data cubes, I kind of wanted to address how the data cubes are similar, yet they are different to some extent. Next slide. Next one. Okay. So where I see kind of the major difference is that the Open Data Cube and all the other ones that were presented are either directly using Open Data Cube technology, or they are designed in a similar way. They are focused on building tools for users to actually access this data, right? And this is what they are meant for, and that's perfectly fine. What we wanted to build really is a tool for people who build tools for users, right? So the focus is a bit different. Now, obviously, you can use Open Data Cube to create your own tool, and this is, you have a nice examples of Digital Alert Africa being exactly that. And you can also use Eurodata Cube directly by just accessing the data, but the focus still is different. That we are really trying to build tools for others developers, where the Open Data Cube is built for actual scientists and users. Next slide. Now, I will not go into all the details because you've seen it in the video, or you will go in and look at it. But the Eurodata Cube is quite a complex piece of software combining several modules which address processing raster data, processing vector data. That was one of the questions I've seen on Slido, and making the vector data available also in an analysis ready form to be integrated with the data cube. And then the hosted processing, availability of data through the X-array based environment. So all these things that are relevant for the data cube. Where there is an important point, though, is that all these complexities are actually exposed to users via a set of, let's say, 3 groups of APIs. First, we have the OGC compliant APIs, which I think are perfect for integration in the off-the-shelf tools, which simply need to work. And you can access all this data through it. Then we build the Python interface, simply because we feel that Python is, let's say, the main programming language for remote sensing science. And we wanted to put a special focus on making the data as efficiently available as possible in Python environment. And then there are a set of proprietary APIs, simply because OGC still doesn't satisfy all the advanced requirements of the data cube features. So we decided to build some additional ones so that users can get all the advanced features. And then, so you have all this complexity exposed over a set of 3 APIs, and then you simply decide which one of these you will use for whatever purpose. Next one. And the first example of such a use is the GEO browser, which hopefully is known to all the participants of this talk. Next one, please. Which is, the point of the EO browser, why I chosen it for this, is that it's really simple application, right? It's a web application which doesn't know anything about satellite data, remote sensing, data cubes, nothing at all. It simply uses the web services in order to give to the user the relevant functionality so that the user can do, let's say, most of this analysis. Obviously, it's not meant to be for like hardcore research. It's meant to be for raising awareness and to do some basic things. And you can really do this easily in your browser. And if you are interested in how this is done, you have a GitHub link down there on the right side, because your browser is open source, so you can go and take a look, and you see that there's really no magic happening in the application itself. Everything is done on the back end with the services. Next one. Now, so EO browser was built by us, but what is more important is that you have hundreds of applications which are built by our users, right? That they build the applications for the end users, and many of them are focused to precision farming for obvious reason, because agriculture is very important and because the satellite data are very feasible for monitoring the agriculture. So you have really lots of applications who use our services, and the users don't even know that they are tied to our services. They simply access the data, and that's perfectly fine. Next one, and maybe just go to a next one. Next one. Sorry about that. Yeah, I expected that I'll do my own moving. Now, another example is Pictera, which is a machine learning application, which also uses the same set of services to provide to the users the way to basically label the data that they are interested in, and then perform the generic machine learning exercise. And again, powered by the services so that they have access to complete Sentinel archive. Next one. Now that is an example from Maxar, from their defense-based application, SecureWatch, which also is using the same set of services to provide, in addition to their own very good satellites, the access to the Sentinel data. So all of these are powered by the same set of services built by, operated by the Eurodata. Next one. Now, I mean, these were the applications with, let's say, quite a easy and simple workflow, but you can do a very advanced workflows in the same way. For example, TomTom, one of the largest navigation companies, they're using the same services to create a world cover, the land cover on the global scale. So they basically access the data through our service. They do all the magic of classification and so on, and they are doing this on the global scale. And it works fine for them because they can focus on the machine learning, on the classification part, not on this basic data processing. Next one. So I just wanted to conclude with these two links. So for those who are interested, definitely you should go to eurodatacube.com or sentinelhub.com. These things are very much related for obvious reason. The next link is if you are interested to get access to it via ESA-sponsored access. You can go to this link, but you can also just go and create a trial account and just use it with just your email. So I conclude here and looking forward for a discussion.
Thank you very much, Grega, for this presentation. We could see that the Eurodata Cube is the place to go for Sentinel data, and you have a lot of facilities, and we have seen, and this is great for all the speakers, that you already work on interoperability between the diverse data cubes, because this will come into the questions. So maybe we will go to the questions part now, if you are all ready. Yes? Okay. So Slido has been very active while you were talking, which is really great because the topic is high tech and it's complex. So meaning that a lot of people have seen the videos, and I'm super happy that there is such a dynamic. So I will take the first question from Laurent Durieux. There are national, continental, and on-demand data cubes with risk of duplicate. Is there any coordination proposed and envisioned by GEO at the global level? Maybe I will give first the floor to Brian and then to Gilberto for this question. Because Brian, you talk about a new community activity on this topic, right?
Yeah, so the Open Earth Alliance was a concept as a GEO community activity that might get more involved in the implementation as well as prototyping some of these ideas. I think Gilberto would agree that a lot of this could come into things like a common API or other possibilities to bring all this together. So I'll let Gilberto go further.
Okay, thank you, Brian. Certainly the Open Earth Alliance is a major development to which the Secretariat is fully supportive. But I think what the vision from the Secretariat can be summarized in two words: institutional empowerment. We don't believe any technology in Earth observation can be useful for decision making, for the Paris Agreement, for sustainable development, if it's not supported by local institutions which are empowered to use it on their needs. So the deal here is, I sincerely, as GEO Secretariat, standards are fantastic and common APIs are fantastic. More important than that is to say, how can the GEO member states and institutions and POs use them? Because what is key here is the ability, as we saw yesterday in Joanna's post presentation, to use Earth observation to provide reports to UNFCCC, to the SDGs, to Sendai framework. And this will only be achieved if the nation states, the countries, the institutions in these countries have access. This, for me, is much more important than APIs and standardization. I think this is the main concern now. Not the other things are not important, but this is so much important that this should be our primary concern.
So it's really the uptake by the users to address these needs, right? Okay. Okay.
Yeah. I will not take the following one, but I will let you to you, Marie-Françoise. I'm going to take mine because I was happy to ask to Greg Giuliani a provocative question. What can't DataCube do? That's a good question. Looking to all the things that you have shown in the different presentation, you, but also the other, we have the impression that a lot can be done with that. But have you any restriction to the use of DataCube?
Yeah, Thierry, thank you. I guess that's a really good question, because I think we all are all the presenters, but within the community, I say all the people that are involved in the data cubes, we are really positive and really enthusiastic. So it might be that we are a little bit biased by the fact that we are really convinced by the benefits of the data cube. I guess that's we have to keep in mind that the data cube technology, no matter what the implementation we choose, it's really meant to facilitate the use of satellite Earth observation data. So it's designed for a specific, I would say, a specific use. It's for the remote sensing community, and it has really lowered the barriers to access and to work with the data. So I would say that the limitation that we can see in the data cubes are the well-known limitation that we know in the remote sensing community, and it's not a magical tool that can do everything. It can do a lot of things with remote sensing data that we were not able to do before, but it's not a magical tool at all. So just to give you an example, for the moment, this is something we don't know yet how to do it, to ingest drone imagery into a data cube environment. And I'm really talking about the Odyssey because this is the one that we have experience on. But for example, also ingesting hyperspectral data, we don't know yet. So this is something we also need to learn. So there is a clear limitation also on that. For example, other types of limitations, but these are related also on how we can handle the vector data together with the raster data. That's extremely important. We are not only processing raster data. We need to have both types of data if we talk, for example, of generating statistics, specific statistics for a given region in a country. So that's the things we need to solve. So we have a couple of ideas. For example, we have linked the Swiss Data Cube with one of the platforms that we are developing that is able to manage vector data, so that we can then provide statistics to the decision makers on snow cover or whatever type of information that are requested by the Swiss government. So that's, for me, these are the two main limitations. But really keep in mind that it's really designed for handling satellite Earth observation data.
Thanks to stress this. I think Grega was also maybe have an idea on this question.
I just wanted to add and basically follow up on what Gilberto said previously. I think that the existing technology of the data cubes is quite advanced. I mean, you can do with different data cubes, and I don't think there is a problem if they are duplicated one even. You can do a lot more of the things that they are done with it. So what I think that we really should focus is not what can or cannot be done, but that people really use this. And I mean, both the governments as well as the normal people, because I think that they are under-facilitated to as powerful as they are.
Thank you. Marie-Françoise?
Yes, I was going to invite also Grega to talk, to answer another question from Laurent Durieux, I think, because it was a follow-up on vector data, and I know you talk about that into your video. You provide a way to mix vector data and complete the data cube with vector data. Can you talk about that?
Yeah, I mean, I don't find this a particularly, let's say, advanced thing. I mean, vector data, you handle it in a database. So we simply use the PostgreSQL database, and then you expose this data through a set of APIs, which, same as Gilberto mentioned in the beginning, they are able to provide for a specific cell of the grid, specific time period, the relevant vector data. In the easiest way, you can simply visualize them so that you expose their attributes as a dimensions. So in reality, it's actually exactly the same as with raster data. It's just that you don't necessarily have the full grid cell, right? That's the only difference. But even that you can interpolate if you need to for the purpose of the use of within the data cube. In reality, where these data are mostly used, at least now and in our case, is with machine learning, where you typically want to go and find the labels, which are often vector data, because you have the administrative data such as, a buildings register and land use maps and so on and so on. So you take for a specific set of pixels, you try to find out which vectors are covering it, and then you simply give to these pixels relevant attributes from these vectors. So in reality, just combining different data sets, and similarly, in a typical GIS tool, you see vector data as a raster layer, right? I mean, you can also expose this same kind of raster layer to the data cube.
Okay, we can follow up, I think, on this question with Gilberto or Karini, because you have mentioned machine learning that can require to access some in situ, or did you use some type of implementation also with in situ or vector data into the Brazilian data cube?
Yes, we are using vector data in the Brazil Data Cube too. We are using the samples, the ground samples of land use and cover classes. We are organizing it in our infrastructure. So we use these samples, point or polygons, can be represented by point or polygons. So we extract information from these points or polygon vector data from these data cubes. It's a a very important task that we have to perform. Is a very useful function that we use a lot in our project. And we are using, we are organizing land use and cover, global land use and cover data sets too, that are vector data. For example, in Brazil, for example, the polygons of deforestation or deforestation alerts, we organize this data in our infrastructure to extract information from this vector data from the data cubes that we are providing in our project. So this is a very important task that data cubes platforms have to provide, in my opinion. Yeah.
Okay, I wanted to insist a little bit on this topic because we understand that this data will be accessed not into the data cube, but with the data, satellite data, which is in the data cube, but with a different maybe type of storage and type of access. But yes, this is very important if we want to be user-centric, because most of the pilot scenarios, whichever, will require to have this this mixture of heterogeneous data. So the message here, I think, is that this problem is solved. Not into the data cube, but it's solved. Yes?
And no, may I just make a compliment that what about Karine was talking first? Sorry. But we are really developing also new APIs, more user-centric and much more high level on the top of very good APIs, such as the web feature services or web coverage services. So, for example, what Karine was mentioning was about web services that give us the trajectory of the land trajectories. So we have some much more abstract concepts on top of other services. So this is also another way to complement the integration between the data cubes with the raster and the vector data.
Gilberto wanted to talk to Gilberto Kumara.
Well, I think we have three responses which are correct from the technical point of view. Greg's, Karine's, and Gilberto's, and Greg would also say the same thing. Integrating vector data into data cubes is simple technically, but the problem is not solved. The problem that we face is different. We need to have users using data cubes in the cloud. Okay, so all the data, raster data, is in the cloud, but the vector data that contains the polygons with the samples is not. And the privacy and the intellectual property rights of that vector data have to abide by the user's IP rights and not by the cloud's IP rights. So that's how we need a protocol which does not exist, which is not clearly defined, to make sure that when a user uses a cloud service and she or he provides his polygons of data, that data is completely covered by his own intellectual property rights. And this does not exist. This has to be discussed and has to be agreed as a standard way of doing it. I'm not saying I have the answer. Technically, there are many ways to solve it. But at the protocol level, at the standard level, there's still a need to solve that nicely.
This was mentioned in the session before about reusable knowledge on this property on the data. I let you take the next question, Thierry.
Yeah, in fact, I think there is a question which is going to be addressed to Gregor and also to Brian. Brian, in your video, you're talking about a network of data cube, and the question is also addressed to to the video of Grega about the fact that the client that you develop, Grega, access to a different implementation of DataCube. And the question was also for the network of DataCube. Can we imagine that this way of accessing to different implementation of DataCube and the idea of the network of DataCube is finally something related to a DataCube system of system? So, Grega, Brian, up to you.
I can respond first.
Go ahead, Grega.
Yeah. So, I mean, I think that the answer is clearly yes, and I think that it's happening already. So we are already connecting to several data cubes, if you want. I mean, like if you go to the EO browser, you will see that we use the GIPS data cube from NASA, I think, or USGS. I don't know, to be honest. And then the ProbaV. Now, this is a simple type of use, right? Because we just use the images from there. But technically, the concept is exactly the same. And now it's just a matter of going one level deeper of integration on the API level between the data cubes, which is also happening. For example, we have integrated the Open Data Cube with the Euro Data Cube functionality, so that if you're using the Open Data Cube software, you can actually access the on-demand Euro Data Cube generation. Then the Sentinel-1 processing chain that Brian mentioned, that is again an example of this kind of integration, because in order to generate this Sentinel-1 data, basically we will use the Euro Data Cube technology on demand. So in reality, this is happening already, and technically, I believe that it is again an easy solution. What needs to be done is a cooperation between the different parties that are building these data cubes, and this is why I specifically like this kind of meeting, so that we coordinate. And at the end, basically, it is just a set of APIs which we need to integrate in a kind of a microservices level, right? And the only thing that is important is that these APIs are operational, and ideally that they are fast, so that then you can integrate this in an efficient way. And I think that that's something that will have to be done, because we will never come into a situation where we will have all the data at the same place. We'll always have different data in different clouds, in different locations, in Africa, in US, in Europe, and so on and so on. And this kind of integration will simply be something that is like the way how we talk between each other.
Yeah, I think that last point was important, that I do see that the data will precipitate all around the world in various data cubes. And those data cubes can each have their own API infrastructure. They're going to have data stored in a variety of formats. And if we can figure out how to solve some of these interoperability challenges, then we're going to be able to bring this data together and use it. We're starting to see that already. We can access Sentinel-2 data in one location, Sentinel-1 data in another location, Landsat in another location, bring them all together, and perhaps commonly detect water or something like that. So there are some challenges, right? You've got to deal with things like projections and different spatial resolutions and differences in the bands and so forth. And then, the differences in APIs. So all these things are challenges, but they're not impossible. And if you look at the way things are evolving, I don't think there's going to be one giant data cube. And as Greg has said, these things are going to probably show up in what might be regional infrastructures. And then what we need to be able to do is to grab sources of information and data from various infrastructures and figure out how to operationally combine them. And that'll be the more challenging thing in the future, but it's going to open up an incredible amount of information for advanced science and machine learning and different products. So it'll be pretty incredible where we could go with this.
Just to follow up, because maybe a link with a regional activity within GEO, and Gilberto Camara can also intervene on that, and Fang Nguyen also. We are looking to different implementation of DataCube in different area of the world, linked with regional activities. So do you think that, Gilberto, there will be an interest to try to interact on all these elements for GEO and to tune it in a good way?
Well, I think what we first have to understand that there is, I mean, as the economists say, there is no free lunch. And what we, of course, need in terms of regions are funding schemes that will provide the necessary funding to implement a stable, let's say, 5-year solution that can be accessible to the countries involved. So Digital Earth Africa is a very interesting example of this, where you have funding guaranteed by the Helmsley Foundation partly and by the Australian government on the other part, to develop a solution that will benefit the whole of African countries. So I think that's a good solution for the regions. Of course, similar solutions can happen in other parts of the world, but I think this is how I see a regional GEO. Of course, you can develop a GEO for example, for Asia and call it a regional GEO, but that's not, I mean, the fact that it covers a geographical area does not make it regional in the sense of a public service. So the issue here is a public service that allows many users to use the facility from different countries, hopefully, but in a public and open way, using public data and producing public information. It costs money. It costs much less than the cost of degradation of our environment, but still costs money and costs organization. So the challenge here for GEO is that how can we organize the potential technology of so many qualified individuals, many of them who are in this virtual room now, with a funding scheme that will allow, let's say, global information to be produced at the local level. And I think it is the most important challenge for all of us, as we have seen in the recent COVID. It tells you there's no substitute for public information. So I think the regional GEO, yes, but they need money, they need resources, they will not blossom out of nowhere.
Thanks, Gilberto. Marie-Françoise?
Yes, I would like to take a last question and address to Fang. It's quite connected with what we have discussed before. What is the main limitation to data cube, processing speed, disk space, hosting costs, or something else? So Fang, you are addressing this implementation of data cubes on huge areas, continents like Africa, and which is the main challenge for you that you can see on this size of data cubes and this very different environment for Australia and Africa?
Thank you, Ari, Françoise. Definitely there are lots of challenges, and I should say that we are still learning through this process of operating to continental scale data cubes and platforms. So all of these are challenges, or at least at some stage we have to solve them. And and I think the main thing that our data engineers or engineers are focusing on are really making sure that the data can be accessed efficiently. So, and this is through all these different steps, through making the input data sets in a cloud native format, so that can be efficiently processed through the cloud infrastructure, and 2, improving the ODC underlying code to be more efficient in accessing the data and manage the data, improve the database efficiency, and 2, using more clever ways to doing the analysis. And I should say that we continue to find ways to improve this. So there's really room to improve always, and more smart people start to use these, and there's always good ideas to help us improve these solutions as well.
So Thank you very much, Fang. This is great to have a return on experience on such not experiments, implementations. So I think we are reaching the end of the session. I would like, well, first, because I will not have the opportunity to talk again, to thank you really much and to summarize that my understanding is that all the pieces are there, everything is ready. The issues, there are some issues because it is not magic. It is a complex system that we try to show as something which is magic for the user working in the background, but which is really complex. And so there are still issues, but they are identified. There are return on experience. There are real users. I think you have mentioned, Fang, in your presentation that you have hundreds of users from business, government, etc. So we have this loop to get the return on experience. So I would say that we have everything now to be successful with that. Brian says that he can see an infinite capacity of uses. The message I would like to bring to the partners we have in our eShape project is that they should really consider the data cubes because the technology is not now only conceptual. It's there. It's now there to be used. And what is needed is to have more users, more different heterogeneous scenarios, not only land cover, even if it's a very important one. We know there are much more, and we need more because this is what you are waiting, if I understood it clearly. You want this uptake, you want this return on experience, right? I begin in the order of the videos. Grega, what is your last word? What do you expect? What is your message to the audience?
Use the data cubes. I think that is the only thing that is really relevant. They are out there. They are working. Whatever of them, I mean, either of these that were presented or some others, just use them so that we actually benefit from all of this data that are there.
Greg.
Yeah, I agree with Greg. I think every element are there, and really, I think now we are reaching the time with the technology and with the data that we have that we cannot say anymore. We don't know what happened. So we can really look at what's occurring on a specific area, and we can learn from the past, define the present situation, and we can even model the future changes. So I think that's the main message for me.
Gilberto?
No, main message is GEO has a very capable community, as we've seen, and I can concur with Greg and Greg and Grega. Use the data cubes, but also help GEO, be part of GEO, come to us and help us develop this technology. There's a lot of good people who could help us. We have a lot of good people, but we need much more. Please join the community.
Brian?
Yes, I would say that I think we have a huge number of untapped users in the world, people that have not traditionally used Earth observation data and have seen the barrier to entry just to be too high and too complicated. And what I think the Open Data Cube and some of these things that we've discussed today, they will open up a whole new ability to bring on new users, to get people learning on how to use the data to solve, to answer questions and solve problems. I'm really excited about the potential. I've seen it in Africa and I've seen it in developing parts of the world. So it's exciting. Thanks.
Thank you. Frank?
I think there's an emergent theme here. I would say that definitely we need more users to try to use these technologies, and we can't really foresee what kind of challenges they will face. And until they actually hit those problems, we'll try to solve them.
Thank you. And Karine or Gilberto, we cannot see you, one of you, because we are reaching the end.
Okay, so I can talk. I agree with Barry, and I would like just to add that we have to produce open data and open software to promote the use of data cubes. Just this final message. Thank you.
Thank you for this final message. We have understood that open community and cooperation is important also to keep in the same dynamic to develop these data cubes. Thierry, you want to conclude?
Yeah, I want to thank all the participants and the presenter about the excellent presentation video they have prepared and done. Just to give you some input about the question, we start with 21 questions. We are still we have answered to some of them, but there are still more than 20 questions on the chat on the slide. So I think there is some duty for you on looking to them and try to help the people to answer it. So thank you very much for your participation, for taking your time and in any period of the day around the world. And we have a very nice presentation of all the part of the world on this topic. It's one of the technology. Of course, we will focus on the following one and on the other one on the future, but that's really a very, very good session that we had, and thank you for that. Thank you very much for that.
Yes, and the questions will stay open, and you will receive answers in the next days. Thank you.
Yes.
Bye-bye.
Thank you very much.
Thank you.
Take care of you. Bye bye.
Thank you.
Thank
Bye-bye.
you all. Bye bye.
Bye bye.
Bye.